In this next unit of instruction, we're looking at probability and statistics, and we're opening this unit with a few lessons on basic probability. And I'm pulling from Algebra 2 resources, so this should be a review. So you've seen probability before, and you should know that when we're finding the theoretical probability of an event, it is the number of favorable outcomes over the number of possible outcomes. So like, for example, when you're rolling a die, the probability of rolling a 1 is 1 over 6, because the number of favorable outcomes is just 1. There's only one on the die, and the number of possible outcomes is 6 because there's 6 sides on a traditional die. That means that there are 6 possible outcomes. So that's why the probability of rolling a 1, for example, would be 1 out of 6. Since the number of outcomes cannot be negative, I don't have, for example, a negative number of die, and the number of favorable outcomes can't be greater than the number of possible outcomes, we talk about probability as a fraction or a percent between 0 and 1. And if the probability of an event is 0, we know that it is impossible, whereas if the probability of an event is 1, we know that it is certain. So in problem 1, we're talking about the 8 planets, and you see them listed there in order in order of distance from the sun. So it says I'm going to randomly draw one of the names of the planets and write a report on that planet. So what is the theoretical probability that I will select a planet whose distance from the sun is less than the Earth's? Okay, so this probability is going to be how many planets closer to the sun than Earth over the number of planets. And some of you might not need that level of clarification. I'm just trying to provide what everyone might need. So the number of planets that are closer to the sun than Earth are Mercury and Venus. So that's 2 over the total number of planets, which is 8, and that reduces to 1/4. Similar example. In problem 1, what is the theoretical probability that you will select a planet whose distance from the sun is greater than the Earth's? Greater than the Earth would be these planets, and there's 1, 2, 3, 4, 5 of them. So 5 over 8 is my probability. The complement of an event is basically all of the outcomes except the event. So it should make sense that the probability of the complement would be 1 minus the probability of the event. So sometimes this gives us a helpful tool for finding the probability of an event. So in a taste test, 50 participants are randomly given a beverage to sample, and we are told the amounts of the different kinds of samples. And so we are asked, what is the probability of a participant not getting drink A? So we could find the probability of drink A. And that would be 20 out of 50, which reduces to 2/5. So then the probability of not drink A would equal 1 minus 2/5. So that's 3/5. So if this taste test is repeated with the same number of drink A samples, but more samples of the other drinks, then that means my complement of drink A is increasing. Well, what they're asking is the probability of not drink A. So it's increasing. Experimental probability, we calculate very much the same way. I just want to make sure that you're mindful of the difference. When we're talking about theoretical probability, we're not talking about how someone has sat there and rolled the die over and over again and found that the probability of rolling a 2 is 1 over 6. That's what experimental probability is a experiment was performed and we're using data collected from that experiment in order to find the probability of an event. So for example, in problem 4, 1,000 skateboards were inspected, 992 were found to be non-defective. So the problem is asking us, what is the probability that a skateboard has no defects? Well, 992 were found to have no defect out of the 1,000 that were tested. And you see that here they want us to express the probability as a percent. So that's kind of a big difference between theoretical probability and experimental probability. When we're doing theoretical probability, you'll find that we are frequently expressing our answer as a fraction, whereas in experimental probability, we're looking at it as a percent. And here my percent would be 99.2%. In problem 5, I ask 500 randomly selected households if they have a dog, and of those 500 households, 197 respond that they do have a dog. So in this problem, what they're asking us to do is to use that experiment to predict how many households will have a dog in the 24,800 households of the entire town. So we start by finding the probability, the experimental probability of having a dog. And I find that by taking 197 and dividing it by 500. And that is 39.4%. Your calculator probably has that 0.394 in it. Keep that there, because what we're going to do now is take that and multiply it by 24,800. So 0.394 times 24,800 and I'm going to use this experiment to estimate that 9,771 households will have a dog. Pause your video to work out the your turn problem below.